The technique of using intercepts works well when an equation is written in standard form. Recall that a linear equation written in standard form is ax plus by equals c, where a, b, and c are integers, and that coefficient of a is greater than or equal to 0. So here's an example of an equation that is written in standard form. We have 3x plus 5y equals 15, and we want to find the x and y intercepts so that we can use them to graph that equation. Well, the first thing we need to start off with is the information we know about every single x and y intercept is that the opposite coordinate is equal to 0. For the x-intercept, we can let y equal 0, and for the y-intercept, we can let x equal 0. So we'll use our equation 3x plus 5y equals 15, and one at a time, first finding the x-intercept, we'll substitute that y equals 0. So that will give us 3x plus 5 times 0 equals 15. And 5 times 0 is 0, so that's going to go away, leaving us with 3x equals 15. And if we divide both sides by 3, we can solve for that x equals 5. So that means the x-intercept is going to be 5, 0. For the y-intercept, then the opposite, we have x equals 0. So substituting that into our equation, we have 3 times 0 plus 5y equals 15. But 3 times 0 is 0, so that goes away, leaving us with 5y equals 15. And dividing both sides by 5, we get that y equals 3. So that means the y-intercept is 0, 3. We can then graph both of those points on the coordinate plane. The x-intercept will be along the x-axis. It'll be 5 units to the right. And the y-intercept of 0, 3 will be on the y-axis 3 units up. So then to graph the equation, we're just connecting those 2 points with a nice straight line. So this line is the graph of the equation 3x plus 5y equals 15. And we found it by finding and calculating the x and y intercepts. Let's try another example. We have the equation 4x minus 3y equals 12, and we want to find the x and y intercepts of the equation and then graph the equation. So we start with our known fact of every x and y intercept, that for the x-intercept y equals 0, and for the y-intercept x equals 0. We'll use that to substitute those known values into the equation to solve for the other variable. So one at a time, first with the x-intercept, we have that y equals 0, so substituting that into the equation will give us 4x minus 3 times now 0 equals 12. But 3 times 0 is 0, so that part of the equation goes away, and that leaves us with 4x equals 12. And dividing both sides by 4, we get that x equals 3. So the x-intercept is 3, 0, that ordered pair. Now for the y-intercept, x equals 0. So substituting that into our equation, we get 4 times 0 minus 3y equals 12. But 4 times 0 is 0, so that leaves us with negative 3y equals 12. And be careful, make sure you bring down that minus sign as now negative 3y, because you're dividing both sides by negative 3y, not just 3. And that gives us y equals negative 4. So the y-intercept is 0, negative 4 for that equation. We can now plot and graph the x and y intercept on the coordinate plane. The x-intercept of 3, 0 is 3 units to the right, sitting on the x-axis. It's the x-intercept. And the y-intercept of 0, negative 4 is sitting 4 units down on the y-axis. So finally, to finish the problem, to actually graph the equation, we'll connect the 2 points with a nice straight line, showing all of the other ordered pairs or solutions to that equation. Using the same equation from the last example, 4x minus 3y equals 12, there's actually another method to finding the x and y intercepts. It's another way to look at that intercept method, and it's called the Coverup Method. So basically, this Coverup method says that if y equals 0 to find an x-intercept, we can cover up negative 3y because 0 times anything is 0, so that part of the equation is going to go away. We're going to cover it up. Now you can cover it up with your fingers. Some people cover it up with a penny if it's small enough, maybe with your eraser or a part of your pencil. But that part of the equation is going to go away. You're covering it up. So here I'm going to cover it up by putting a white square over it so that you won't be able to see that part of the equation anymore. So we're covering up the negative 3y. And again, that's because we're looking for the x-intercept, so y equals 0. So this leaves us with the equation of just 4x equals 12. And then we can solve for x by dividing both sides of the equation by 4. And we get that x equals 3. So putting that together, just to see it again, now we have the original equation turned into a smaller equation with just the x variable, and that gave us the x-intercept was 3, 0 from solving for x equals 3. Now, the cover-up method also works for finding the y-intercept. So if x equals 0, we can cover that up and then solve the remaining equation. So if I get my white box to cover up the x part of the equation, then this part would be gone. And now we would be left with negative 3y equals 12. If we solve for y by dividing both sides by negative 3, we get that y equals negative 4. So putting it together, we see that, again, from the original equation, we're taking away the x part of the equation. We're not looking at that variable anymore. And if we only have the y part of the equation, we can solve for that variable y and give us the y-intercept of 0, negative 4. And since this was the same example we worked with before, we can see we're getting the same x and y intercepts. It's just a little, it's like a little trick. It's a little less algebraic. It's just you're doing a little bit of the algebra when you cover up the certain part of the equation rather than substituting in a value of 0 and seeing that work out in the equation. It's a little bit faster of a method, and as you work with x and y intercepts more, you can become more comfortable with this method and use it to your advantage to solve problems and graph lines a little bit quicker. Let's do another example using the cover-up method. So the example asks us to find the x and y intercepts of the equation 5x minus 2y equals 10, and then graph the equation. So first, let's start with the x-intercept. So if we are looking for the x-intercept, we know that y equals 0. And if y equals 0, we can then cover up negative 2y in the equation because 0 times anything is 0. And then we can solve that remaining equation. So let's do just that. So I'm going to cover up that part of the equation. So that is leaving me with just 5x equals 10. So that's what we now want to solve for x. We can divide both sides by 5 and get that x equals 2. So the x-intercept of that equation, 5x minus 2y equals 10, is 2, 0. We can then solve for the y-intercept by doing the same process, but thinking that now x equals 0. So if x equals 0, we can cover 5x up because 0 times anything is 0. And then we can solve the remaining equation. So I'm going to do just that. I'm covering up now the x part of the equation, and that's leaving me with negative 2y equals 10. So to solve for y, we can divide both sides by negative 2 and get that y equals negative 5. So the y-intercept of that equation is 0, negative 5. So now we've solved for our x and y intercepts using the cover-up method, so now we can graph them on the coordinate plane. The x-intercept is 2, 0, so that's going to be 2 units to the right from the origin on the x-axis. And the y-intercept is 0, negative 5, so that's going to be 5 units down from the origin on the y-axis. The piece de resistance is to connect the two intercepts to graph the line that is representing the entire equation, not just the intercepts of the equation, for 5x minus 2y equals 10. Let's try one more example together where we're finding the x and y intercepts of a linear equation, but this time the linear equation is not written in standard form. We have the example where the equation is y equals 3x minus 9. When it's not written in standard form, the cover-up method might not be the best choice to go with, so let's go back to our understanding with the definition of x and y intercepts and using the fact that when we're finding the x-intercept, y would equal 0, and when we're finding the y-intercept, that x would equal 0. So if y equals 0 for the x-intercept, we would substitute that in for the y value in the equation, which would give us 0 equals 3x minus 9. We would then solve for x by adding 9 to both sides of the equation and then dividing both sides of the equation by 3. So if 3 equals x, that means our x-intercept is 3, 0. The y-intercept, then x equals 0, so we can substitute that value into the equation to get y equals 3 times 0 minus 9. And if we simplify 3 times 0 minus 9, we get 0 minus 9, which is negative 9. So the y-intercept of the equation is 0, negative 9. Since we now have our intercepts, we can graph the two of them. 3, 0 is 3 units to the right on the x-axis, and 0, negative 9 is 9 units down on the y-axis. So there we can connect the two intercepts and get the graph of our equation. So whether you use the cover-up method or the definition with the values of x and y equaling 0 to solve for the other variable, you can get your intercepts to graph them and then connect them with a line to have the graph of the equation of that line.